Hello, everyone out there, and welcome back. We, of course, again, are here with another Turning Tuesday video where we are taking things back to the basics, where we are diving into each individual toolpath. As we started out already, we went through the tabs, we talked about setups, and now today we are going through profile roughing, one of my favorite toolpaths when it comes to the turning workspace, because there's a lot of tips and tricks people don't know or how to utilize this toolpath to achieve great outcomes. So if you don't know, I am Fusion Phil over here at JetCAD Cam. I am the owner and operator of this magical beast that we continue to ride on. But with that, if you guys have questions, comments at any time about profile roughing today, go ahead and throw them in the chat, leave a comment down below, or reach out to us on Friday for yet again another free support Friday. So let's get into this. I'm going to go ahead and share my screen. Maybe, maybe not. Let's go ahead and try that again. As you guys can see, I have my screen now shared. If you want to work along with these parts in particular, now the strategies we're going to use are pretty much universal across all parts. But with that said, you can go ahead and go to the Home tab in your user view space. Down at the bottom, you have CAM sample folder. In that CAM sample folder, you will see that you will be able to pull these parts with the same name. Now, full disclaimer, guys, I do have one part. There's a use case there that you won't have a part file for. However, again, the system is universal. So let's start things off. As we like to say over here, we have a couple of rules when dealing with Fusion's CAM workspace. Rule number one always is top to bottom, left to right as we work through our menus. So with that said, you can see I'm already in the Manufacturing Workspace. So we need a setup on our part. Now, we did do a video specifically on setups. I'm not going to spend a ton of time here, but you guys are going to see we're going to go ahead and pick our part, make sure our Z-axis is pointed the way that we want it. And from there, I'm not going to concern myself too much about jigs and fixtures today. What this has allowed me to do is now give me an X-axis for working. And with that X-axis, I can go ahead and go in and do a section analysis. Again, full disclaimer, guys, this part in the default library has an origin in the middle of nowhere. As you're seeing, I'm able to kick that on at any time. And what I'm doing with that analyzation is the ability to just see a half profile of my part. So let's dive into this, right? The reason why we are starting with roughing toolpaths is because normal circumstances, a lot of you out there might want to face off your part. But if you look at the example here, you're wasting a lot of cycle time facing off something that we could probably do with a finished toolpath or minimize the amount of facing. So let's go ahead and pull up our turning profile roughing. From here, I got to give you guys, this is rule number 2. Rule number 2 is the fact that when in doubt, okay your way out. This is the biggest mistake we see done by people is they want to go in here and they want to start changing things in their menus and picking things and doing this, that, and the other. However, if you never get blue lines on your part, we can never troubleshoot the issues. For example, right off the start, the software is requesting from me to pick a tool. So as you guys can see, again, I'm going to stress this out as much as possible. We are going to be using Fusion library tools. So I'm going to go ahead and right click on my Fusion library and make sure I turn all of my libraries on. You guys are watching our Milling Monday series as well. You'll need that turned on as well. So let's go in. We're going to go with a turning general tool in our filtering on the right. And then I'm going to go for a CNMT right-handed tool. So with that being said, you can see the software has now already started to populate my toolpath, right? So from there, I'm going to go ahead and turn off my in-process stock. And if you guys want to do this on your end, you can use the F8 hotkey. That gets rid of the model. As well, under your turning profile visibility down here, you could show your rest material and a spun profile if needed. Again, as you guys are now seeing, I have a yellow stock in place versus that green solid model of my stock. So again, I'm going to turn them off for demonstration purposes. And this just allows me to see the toolpath, show you guys a little bit more of what's happening on our part profile. So now that we have actually just applied a profile roughing, we get to play the game of rule number 1 all over again. And to basically sum this up, we have everything from our tool. We're going to move to our geometry, which again is our Z axis as a reminder. Our radii is our X axis. Moving a little bit further on, we're going to deal with the blue lines themselves, or as they're called, the passes tab. And then everything that's not a blue line is going to fall into our linking tab. So the very first thing I'm going to look at when it comes to this series of tabs is we've given it a tool. There's really not much more we're going to have to do in this menu. Now, if we gave it a boring bar, it would automatically change from outside to inside profiling. So this is why we could actually skip on to our next step, which is going to be, is my toolpath going where I want it to on my geometry or in my Z axis direction? Well, in this case, no, right? We are stopping short at the back of our part. Now, one thing you're going to notice on this part profile is we are not actually turning anything on the OD of our part. And the reason for that is because my stock and my part are an identical diameter. So let's fix that. Again, I'm going to go over to my setup. You can double click or right click edit. Go to my stock tab. And we're going to go ahead and change that stock diameter to 2 3/4. And as you can see, that has become much larger. Again, we have a video on adjusting your setup altogether, but we're going to go ahead and do an offset from front to make this a little bit more realistic when it comes to our path. So again, we can now regenerate our toolpath. I'm doing this with the hotkey Control-G. You could have also done this with nothing more than a right-click generate. And as you can see, I've now created a lot more blue lines, and they are now respecting my geometry and my radii. Another tip here when you guys are getting started in Fusion, you can go down to the toolpath menu and you can turn off things like your linking moves, making it a little bit easier for you to see the colors and the kind of geometric shape that the toolpath is making. So the very first thing, again, now that we can see a lot more toolpaths, is let's get our part to turn a little bit further back, right? So rule number 1 says we should go to our geometry tab, and now we should adjust our back location, right? Because we are machining from the front, which is model front, all the way to our model back. Now, this is something that could get us in trouble because we might want to start at stock front since we did not, in this case, face off of our part. We also want that stock back, not stock back, I apologize, guys. We want to extend the back to go further past the back of our part. Now, as you're seeing, I'm clicking and dragging on the back segment, and we're getting a offset of 200. Now, the distance that we travel past right now is very important. Remember, when it comes to if I'm going to part this part off. Again, the reason why that is important is we probably want our parting tool to get into a nice area. But what's going to happen is, as you're going to notice, we are now waterfalling down the front of the part right here by my giant balding head. And we are doing what's called a waterfall or undercut up here in the top left corner. So why that is right off the start is when I forced the geometry to recognize stock front or to utilize a offset compensation, it is allowing that tool to get down and around my part, right? So I want to remedy that. Well, how would I remedy that? On the back side of my part, instead of using an offset, if I was to plug in a tangential extension, you'll notice that it's going to take a last segment used. That last segment, in my case, tends to be perfectly flat, and then extends past that 200, carrying a straight line. Now, why that is so important to know as well, what I'm going to do is with this waterfalling undercutting move inside of this groove, is I am making these adjustments all based on the geometry of my part. Now, we're going to go ahead and we're going to actually go to model front. Again, if I go to model front and I say, or not model front, front mode, and change it back to model front. Now, if you guys have changed something and you can't remember what it is, this is where we could use the 3 little dots, and we could either reset to your user default or reset to system default. And again, we can do a tangential extension on the front of our part. So again, I'm going to add in a 0.1 just temporarily so that you guys can see once again, based on that last segment used, which is flat, we are now starting straight off that front profile of our part, because next week's classes, when we talk about profile finishing, we're going to be able to come down with that tool and clean up that front face. Again, eliminating an entire operation and possibly even a tool change depending on what you're doing. So again, from here, we've now got our tool path to start far enough out. We are going far enough past in the back. And if we look at our menus, again, I can't stress this, geometry is all about constraining our tool path in a Z direction, but this does also rely on things in the X kind of motion. This is why we could move down a little bit further and use something like groove suppression to eliminate this waterfall. As you guys are going to see me do, I'm going to go through it. I need to pick both walls and the segments in between those walls. So if I go ahead and square back up to the side of my part, you'll now see I have a blue line to blue line from left to right, and I can hit OK. And just like that, groove suppression has now allowed me to skip over that groove. Now, this is very important because some of you out there are advanced users inside of Fusion, and I'm surprised nobody's put it in chat, that why wouldn't I instead, if I did turning profile rough here, you guys are seeing me just create a brand new tool path, why shouldn't I turn off allow axial and radial grooving? Yes, this will remedy the idea of not plunging into this profile right now. However, if you were to change directions in our passes tab, so again, instead of going front to back, I went back to front, because that tool cannot feed back in the X direction, and that's basically what radial grooving is I cannot go in on X. Once I start in X, I can only feed out in X. So back dragging this part or using kind of a lollipop cutter or a dog bone, I wouldn't be able to plunge back in here in the front. Again, this is why we always say start as early as possible in these tabs. Use rule number 1 to your advantage. So again, if you guys were to look at this one more time, if I was to go to my passes tab right now and say back to front, or even both ways, what you'll notice is my tool path hasn't really changed, but when we simulate this, we are coming in on our X axis. So just keep that in mind. That is why we have changed our curriculum on our end to always utilize our radii menu as much as possible. Now, this is something I have curiosity about because we do have what's called rest machining as well. And this can be utilized from setup stock or from previous operations. And what this could allow is, we're going to see if it's going to do it. It is going to do it, which is awesome, is now rest machining has trimmed all of that tangential extension off to put it where our initial stock profile is. You guys are wondering what I'm doing right now is I'm using the control key to hold on here. And again, we've now auto trimmed that tangential extension. So again, rule number 2, when in doubt, hit OK. But rule number 1, top to bottom, as you guys saw, we went ahead and when we turned on our rest machining, we've eliminated tangential extension. So again, this is something to keep in mind, is when using rest machining, you give up certain things as well. You may or may not add or make a bigger problem with what you're doing. So that's why I'm going to go ahead and turn off rest machining, because I do want my tool to go past the back of my part, and I do want it to start in front of my part. Now, this number is a little large. As you guys know, you could adjust that down. I haven't done it, but you could also create what's called an expression that will utilize your offset that you've put in your setup. So from here, as you can see, this is looking very well. Now that I've got the blue lines in Z, I'm going to go ahead and shift gears, and we're going to talk about the blue lines in X. Well, there's not a lot here that we need to worry about because this is an outside profile toolpath, and we're not feeding down towards center anymore because, again, we've already adjusted that based on the geometry tab. But I do want to run through this real quick. It's easier to understand inner, outer clearance because we are working based in the opposite direction, right? We are starting at our clearance height, which is this orange. We're going to come down to the outer radius with our tool, and then we are going to work towards our inner radius. These are all driven from our setup, and there's not a big need for adjustment here. We will see an adjustment, however, later when we start to work with boring operations. So our next step is to talk about the blue lines, right? So again, when we're talking about profile roughing, you have what's called cycle and direction, which is, as you've already seen me do, which direction do you want blue lines? And do you want to go forward, backwards, both ways? Again, do you want to allow grooving? Maybe you don't want to allow grooving. And additional adjustments outside of this. So one good one that I like to do to people is, let's say we go vertical passes. And as you're seeing, is if we hit OK, we've now changed the orientation of our blue lines to kind of feed in, outside in, as if it was facing or kind of doing a part off motion down the entire length of our part. Again, dependent on your tool. If we stayed horizontal, you could also do things like both ways, allowing our tool to maximize back and forth, back and forth. And if you guys can see this out there, it's kind of doing an S curve now because it is going to feed in and then pull back, feed in, pull back. A few other things that you have the ability to adjust here based on this part is, if we went ahead and go back to front to back, is moving a little bit further down, we have things like the ability to adjust the pass itself. Now, this is where I like to say, this is our orientation or how the blue lines are removing. And now we're going to fine tune that based on things like, I want more or I want less blue lines. So let's say I say 0.1 maximum depth of cut. Again, now you're seeing we're taking a bigger depth of cut, which means we reduce our blue lines. A few more adjustments we could make here on this part is we're going to go ahead and go down. Now, some people don't understand what use even depth of cuts are. Again, this is really nice because it will reduce our maximum depth of cut so that if you've ever turned a part and that very first pass barely skims any material, we can actually make the tool consistently cut and consistently wear that tool. So again, very handy thing. You're not going to see a big change here, as you guys will notice. However, it does make quite a bit of difference when you're running that machine. Going back one more time into the passes tab, this is one of my favorite ones, is the ability to go through and use pecking. So if you're dealing with a kind of material that is plastic or brass, something stringy, we can actually do a pecking cycle. Now, you're probably not able to see this right now. So I'm going to go ahead and swap out our toolpath, and we're going to turn on points. And then I am going to turn linking back on. Actually, we're not going to need linking. And let me know out there in chat, guys. Maybe we should switch my background altogether. Let's see, is this a little bit better with a photo booth? Should be able to see those blue lines, I think, a little bit better. You can also see me lit up on the screen a little bit more as well. I'll dim myself down a little. So, as you guys are seeing, again, we now have points on our toolpath. Every time we have that point, we're going to feed in and we're going to retract a little bit, right? Because we're pecking. We're going to feed in, we're going to retract. We're going to feed in, we're going to retract. Again, these are all additional adjustments we're making to how we are removing material. Again, as we like to say, you have geometry for wear in Z, you have geometry, or not geometry, radii for wear in X, and now we're messing with the how to remove that material, right? So again, moving down a little bit further, we're going to go ahead and turn off pecking for this, but you do have things like your stock to leave. Again, this is how much material do you want left on the part so that we can come back and make a finished cut. Now, this is something that's a little more unique to lathe. It is a milling thing as well, but in some cases, your next finishing tool requires more material to get a bite. So again, what that is and what I'm saying about that is if you've ever turned a part and it seems like you cannot adjust out a consistent finish pass, is you are no longer cutting in some cases, you're rubbing the part, right? Or you start your cut and it makes a little bit of a cut and then it kind of stops and falls off. This is all things, as you guys are seeing, is the ability to adjust, again, the amount of stock that we're going to leave on that part. So lastly, what we're going to do is we're going to go ahead and swap over one more time. This time I'm going to turn on the linking tab and we're going to turn our leads and cutting moves all off. And this is where I think I'm going to have to adjust my screen. Let me go ahead and go back into my environment. Maybe we could find one that works overall. Actually, this might be it, guys. Let's see. I think can you guys see that? You can see all that now. We're going to stick with the gray today. So lastly, we need to talk about our yellow lines and how those yellow lines are going to work when we get to the blue lines, right? These are our linking moves. As you guys can see, we could do everything from preserving your rapids, always using high feeds. This is a big one because some machines in a rapid G00 only move 100 inches per minute. Using high feed, we can override that and force a completely different feed rate to move from cut to cut. So again, moving a little bit further down, this is some ones that I really enjoy adjusting is our approach and our retract. So I could actually say safe Z. We could go to first toolpath point. Again, as you guys are going to see, is it's actually moved our starting point in. And again, if we go back to our other, we have our approach in X, first toolpath point. You're going to notice it is now moved again down below. So based on what I'm adjusting right now is I'm changing my starting and my ending points for my toolpath, right? So again, you could go a little bit further than that. You could say last toolpath point, last toolpath point. One thing I want you guys to pay attention to, though, is you do have in here safe Z, and you also have clearance, right? So again, you also have those adjustments will make a big difference, but they're still being driven when you move further up in your toolpath from clearance, for example. So just keep that in mind. We're going to go through a couple of scenarios why that would be important. And as you guys seen, I've turned everything on to first and last point. Again, this could be dangerous depending on your machine where we're going to stop that cut. But from this point, we could go ahead and simulate this tool. As you guys are seeing, my tool is like right on top of my part and immediately starting to make my cut, right? So by making that adjustment, we are getting really dangerously close to my part. We're going to go ahead and stop dragging on my screen here real quick. So it might make you pucker up a little bit, pre-warning, right? This is why we always recommend to people is make sure that you're not making adjustments if you're new to Fusion. Go ahead and leave a lot of this based on its original settings because it will help you out for not crashing your machine. Again, as you guys are seeing, I'm going to change everything back to safe Z and safe clearance. Again, now my tool starts and stops from a safe location. This is advanced moves for you guys out there. You've ran the part. Now we're squeezing cycle time, right? So again, seeing that simulation, you'll see we start a ways away from our part. Then we dog leg down into our cut. Again, staying pretty close to our part until we're going to get to the end where we'll have our final pass. We'll retract back out. Again, we'll go ahead and back drag that in. We're making our final cut against our profile, and then we're rapiding back to that known location. So let's start to dive into a few more scenarios here. So I'm going to switch gears. We're going to look at another part, and this time we're going to move a little bit faster. So again, I'm going to go in, create my brand new setup. Now on this part, we're going to go ahead and utilize a different kind of stock because we are going to shift over and look at interior or inside diameter type stuff. As you guys can see, I have my XYZ again. I have my stock size. And if I wanted to go through and just start working on the outside of this part, as you guys saw me do before, we're going to do our turning profile using rule number 2. Let's hit OK. And in this case, let's do the outside first, which means I'm going back to my library, good old-fashioned right-handed tool. And just like that, you guys are seeing is we've now created that profile. In the case of this part, you're going to notice that my tool path, again, is waterfalling because of where that groove is. This is why we have settings like show spun profile. And now you'll see, oh, well, when it spins this kind of cog, we do have a groove there, which again is why we're falling into that groove. So again, we go through and adjust our tool path. We look at our geometry. In this case, I'm not going to adjust my front or my back, but we could go through and we could do our groove suppression. I actually am going to adjust the back settings here. As you guys can see, we now have done our groove suppression in that little area. We have trimmed off where we were plunging into our cut. Now, had we done this part in a dual spindle kind of scenario, it would be better. And if you guys are wondering, I just did an undo there. Maybe I would like my geometry to stop at a specific back location. So again, we're going to go back mode selected, this face. And in this case, you'll now see we're roughing in to where that flange is at the end of the day. So again, this is one of those very, very common ways to stop your toolpath short using geometry without turning the whole outside profile. But let's look at what I think a lot of you have come here for, which is going to be changing gears and looking at a boring cycle. So again, we go turning profile rough. In this case, we're going to swap out to a turning boring ID boring tool. This is in the default tool library. If you guys didn't know, as you're seeing, I'm going to hit OK. And of course, I can't see my part or my tool path. This is where we're going to do a section analysis. And I'm going to use that plane to cut my part in half, allowing me to see my tool path. Now, as you guys can see, once again, we've actually gotten a really good tool path off the start. And the reason for this is because, one, we defined our setup and our stock. Very, very important details here to get it correct out the start. Again, go back and watch those setup videos. Leave me comments to tell me why they're so terrible or what I missed out on. But as you guys can see, again, we have what is almost perfect to be able to come in, do our boring cycle. Now, we may not like this at the end of the day. Sorry, guys, I'm picking the wrong button here. Is because if you notice where this tool is going to go for a safe location, as you can see, I'm hitting the backside of that tool before I get down into that cut, right? So this is something, again, the simulation is going to be your absolute best friend. And the reason for that, Hollywood magic out here, guys, is if we go ahead and turn on our pressed machining, and we look at our tool path, our stock, again, my setup is going to haunt us, but I've simulated this to find out the backside of that tool is going to hit. Now, we could make some adjustments to it. Again, we could either do a tangential extension, which is what I'm going to go for here. So we're going to say model front, and we're going to offset that based on an increment of measure that I don't know in millimeters. But let's go ahead and just say it's 5 millimeters off, actually not offset. Tangential extension, guys. 5 millimeters. And what you're going to notice is now our tangential extension is going to miter because, again, we are tangentially extending the chamfer right now, right? Some of you, again, are probably questioning, well, wait a minute there, Fusion Phil. Tangential extension is, waterfalling and undercutting the part. Why not use offset? Well, had I used offset instead of tangential extension here, so let's go ahead and zero that out and put 5 millimeters in, what I've done is I've now allowed the tool to come around the part and not be trimmed at the tangential extension segment, right? So this is, again, where the Hollywood magic and tricks that I will show you, which is going to be, instead of utilizing our model front, we could do a selection. I'm going to pick the lower edge of that chain because that is going to be where my bore is. Again, we're going to go ahead and zero out offset as it should be before you start typing in things. And we're going to put our tangential extension in 5. Now, as you guys can see, we are tangentially extending the bore, not the chamfer, and we are starting plenty of far enough out to avoid that stock. So again, if we were to simulate this now, you'll notice that we don't get a crash. However, if my tool was ill-defined or I was having other issues with my settings, it's a little worrisome to me, in my opinion, to rapid to the inside of my bore and then move outwards to my cut. Now, again, this is going to be something based on the radii selections, and we can narrow that down. So again, we go to geometry. We're going from a front location to a back. That looks good. There's no grooves to talk about. And as well, there's no rest machining. But this is where, again, I love Fusion. The visual representation of what is going on right now is all explained once you use rule number 2. You hit OK, and boom, you have blue lines on your part, as you guys are seeing here. Now, I just need to see what line is coming from where right now in my radii, right? If we actually were to rotate our part, you'll notice the radii menu is cylinders, right? So looking at that, in orange is my clearance, which just so happens to be where that toolpath is working off of. So again, if I rotate around, not very often we tell you guys to change certain settings, but what is happening is based on our clearance right now, we are from our stock ID, and we are in this case 10 millimeters smaller than whatever that is. Me personally, you guys take this for what it's worth, is I would much rather set this based on my inner radius. So clearance now looks at inner radius, and then my ability to offset can be much smaller. So let's say I'm going to go 2 millimeters in this case. Now, some of you guys are out there wondering why I'm using the increment that doesn't get us to the moon. That's debatable. I would measure in bald eagles if it was something I could do. And you could switch your increment of measure out at any time from millimeters to inches, as you're seeing me do here. But the ideas are still the same. The same workflow applies. Is as you can see, I've now moved my toolpath further out, right? So if we went back into that toolpath radii menu, let's go ahead and say I want to go negative 50, making life a little bit dangerous, but we're getting pretty close to the wire. But we are now going in when we simulate, we are rapiding. Oh, simulating the wrong toolpath here, guys. Pro tip right now is if you want, you can right click simulate, or what works really, really good is the S key on your keyboard, because you can map your own shortcuts. As you can see, I can immediately go into simulate. But as you're noticing, my tool is starting further out in my bore because I adjusted my clearance in my radii. But it does get better than this, guys. You're noticing that I am making some changes here along the way. Again, we could talk about, how confident are you with your machine? I might take this one step further, which would be is on my linking tab. We could approach an X based on first toolpath point and then retract back to our clearance. So again, as you'll notice, that very first cut is where we are going to rapid the machine down to. Makes it a little easier to understand looking at the controller. And then we immediately go into our cut, but then at the end of everything, we're going to come back out to our clearance and retract out of our part. So again, we could adjust this as much as we want. We have that freedom to go into our passes tab, front to back, horizontal. We can adjust our maximum depth of cut. Again, how much stock to leave on our surfaces. As you're seeing, let's go ahead and leave not 75. We're going to leave closer to like, 7.5 here. Again, 7.5 here. And I like a little bit more of a sturdy depth of cut. And just like that, you guys are seeing we've now made some changes. Again, the color coding is always going to be your best friend when dealing with stuff like that. But let's look at probably the most common error I see when it comes to toolpathing inside of a bore. And we're going to go back to the quick release hub for that. Now, again, I am going to base this off a change to my stock, and we are going to set this up as if it is a piece of tubing. Now, this is where I'm going to pause for you guys. Normally, if you're solid material, you're going to drill this and you're going to have said known diameter drill. I want to make that very clear out there. And what's going to happen is I am going to set this to, let's say, 3/4 of an inch. I'm not going to show you a drilling toolpath today because we're going to save that when we work a little bit further through in the next couple of weeks. But what I'm mainly looking for is a pro tip here is we still have our stock inner and our stock outer based on our toolpath. Actually, hold on here. We got to create a brand new toolpath. So we're going to go turning profile roughing. Again, we're going to swap out to a boring tool. As you guys can see, I don't have a boring tool. Pro tip here, if you're using the same tools across multiple setups, you could go ahead and jump over to your other part here on the left in your documents area and recycle a tool. And we're going to hit OK. Now, I did get this error, which makes me extremely happy, right? And that error is toolpath crosses rotary axis. Not the biggest deal unless your machine has a travel limit in X because of the center line of the pocket for your tool. So that said, we can fix this in a couple of different ways. So again, we could look at our part. We could say rule number 1 left to right, top to bottom, front apart to back apart. We are boring in the correct direction of X. Moving a little bit further on to our radii menu, are we working within our radii properly? In this case, no, right? So as you're seeing is my inner clearance, and again, this is why we can't stress enough that I like the idea at the end of the day of setting this to look at inner radius, which is still stock ID. And from that, our offset in this case, we could decrease that amount so that our tool initially is now going to start on the positive side of our X axis, right? Instead of being so low in our negative X and possibly over traveling your machine. Again, we could remedy this by going to the linking tab and using first point, last point. But I want to show you why it's my opinion that when we talk about the inner radius and the clearance being linked together is because had you drilled a hole in the center of the part right now, you wouldn't know what size that hole is, right? Now, you do know what size the drill bit is, but Fusion would not recommend or recognize the stock ID at that point. That's where we would use what's called a diameter for inner radius, and you could plug in whatever size that drill bit was. And as you notice right now, my clearance shifted out because it is linked to inner radius. So again, let's say it's an 875 drill. Let's go back and make an adjustment back to, maybe it's a 1/2 inch drill that we initially drilled in this part. You're noticing that my toolpath is automatically clearancing based on whatever manual diameter I typed in. So with that, I see a lot of you guys coming and going. I'm going to give you a moment here. If you guys have any questions about profile roughing, feel free to throw them in chat. I am going to pause for a moment before we come back and we look at a couple of scenarios of a little bit more of a grooving scenario inside profile roughing. But I do want to put it out there to you that at any time, if you guys like what you're seeing right now, feel free to go ahead and hit that like button, subscribe to our channel. You could also buy us beer, steaks, and lobsters on our website. We also, as a running joke now, have done memberships with a lot of you guys are liking, and we've even modeled them after a beer, a steak, or a lobster tier subscription, or not subscription, membership. But I also want to remind you guys that if you're looking to get some really good free training out of yours truly, we are hosting a 3-day boot camp right now down in Tampa, Florida, in the middle of February. Again, link down below to get signed up for that. Now, that is an in-person class. We will not be doing that online. You would need to fly to Tampa in the middle of winter. Kind of why we're doing this. I live in North Dakota, guys. So getting back over here, let's shift gears a little bit real fast. We're going to go to another part. Now, I did warn you guys, this part in particular, again, is not in the default library, but as you're going to notice, the system we use is still universal. Again, we create our setup. We make sure our X is pointed the right way. Maybe our stock in this case is going to be a little bit bigger. Let's go 525. And then my length is 1.25. Again, offsetting from the front. Let's give it about 50 thou, right? Again, I like to do my section analysis. I can use one of the planes at my origin. And from there, you guys are now going to notice we have quite an interesting inside profile to this part. So if we were going to go in and start boring this part out, first things first, I need to adjust my stock back to a tube where I'm messing up. Again, inside of that tube, let's say it's 2 inches. So let's go ahead and pull a couple of tool paths together, right? So again, we're going to do turning profile roughing. I'm going to go ahead and select a tool. This is once again, just jumping back to one of our other files, pulling the CNMT tool out of the Fusion library. And of course, using rule number 2, which is hitting the OK button. Now, depending on your workflow or what it is that you guys normally do in your shop, yes, we could come in here with an ID grooving tool. But being realistic about it, we don't necessarily need to because the relief on this part is about 45 degrees. So before I get too deep into trimming this up and making it all fancy, let's go ahead and do another turning profile rough. And this time, I am going to copy or duplicate this tool because what we need to do is make a quick edit to the tool insert itself. So we're going to jump over to insert. Now we're going to change it out from an 80-degree diamond down to a 55 degree. Again, we might need to go a little bit further than that. Let's do that. Let's go down to a 35 degree. And what I'm really looking for is a lot of relief, more relief than 45 degrees. Yes, this is an unrealistic tool, as you guys will see, but I want to show you just by default, hitting OK here, we have now created a tool that will get inside that workspace. But if you know about turning, the VNMT is more of a finishing tool. It's not really meant for heavy boring, stuff like that. So let's now take our two toolpaths and get them merged down and get them combined so that they work together. So as you're going to see, I'm going to go back into that toolpath. Real fast here, I'm going to turn on rest machining for when we're using that VNMT cutter. And as you can notice now, we have automatically trimmed that down to whatever leftover material is still there. We can use that to clean it up based on what's happening. Now, one thing that's usually a rule of thumb in turning at the end of the day is you never really want like a sloped surface to come back and start to work with. So let's fix our initial roughing strategy. So again, we're going to go in, we're going to go to our geometry tab, and a couple of things we're going to want is we want to go past the back of our part, again, alleviating as much material as possible. I'm going to go selection. I'm going to pick that inner chamfer and do a tangential extension. Again, I'm going to use 0.2 for reference. Again, we're going to need to make a few more changes here because I put in some of the wrong information. That is the front, as you guys can see. So let's do it this another way. We're going to undo real quick and then make our change. Even the best of us make mistakes, guys. So again, we need to go to back, selection, and then do our tangential extension. And then as you're going to see, we're now boring out the entire inside part of that slug, right? But this is, again, where I need to use not, don't do this. It's a bad habit. It's hard to break. Don't just jump over here and turn off groove, right? We should respect the fact that we have what's called groove suppression because there's going to be times where you guys are trying to get very unique toolpaths with multiple grooves and profiles on your part. And that groove, turning off axial and radial grooving will actually cause most of your problems in your toolpath. So again, you guys are seeing me turn on groove suppression. I'm now just boring straight through my part as I would endure and really like to do. So again, we go down to our second toolpath. We can go ahead and regenerate that toolpath. Again, we're now making a clean cut across the inside profile here. However, we're plunging on the backside. We're also machining this little chamfer here. And again, there's multiple ways we could adjust this out. Let's use rule number 1. And let's start with the concept, are we at the correct front? Yes. Are we at the correct back? No, we are not. So again, I could say selection and narrow down my toolpath to work within a specific Z area. But again, we have that fun of adjusting our now radii because we may be clearancing way too much, moving a little bit wild and all over the place and making those adjustments. So again, we jump into radii. I would have set this as a user default, but due to the great world of me training people all the time, if I changed it to a user default on my end, I would forget to express to you guys how much you should change it. But as you're seeing, we can now walk through and start to clean this up. Again, this is a profile being done, profile roughing with a tool that does have proper relief to work within that area. So I don't see many questions. Didn't see a ton of you guys, which is pretty common. Seems like everybody loves milling on Mondays, turning not so much on Tuesdays. But if you guys have any questions, feel free to throw them in chat. And as I will throw it out there for you guys, it's not what you know, it's who you know. And if you guys have questions, problems, issues, want custom training by yours truly, we do have a promo sale right now on our support as well as our online hourly training. We also offer custom in-person training. And of course, if you guys want us to come out to your area and do training, by all means, get us in contact with the machine vendors around you and get them to host one of our free Fusion boot camps where you can meet yours truly and buy me a beer in person. So don't forget to like, follow, subscribe. And as always, have a great time. I look forward to seeing you guys back here on Free Support Friday.